Alrighty, so with this video we're going to continue our discussion of linear algebra. Last time we started talking about matrices. Remember, a matrix M is this mathematical object. It has some number of, it contains elements, numbers, operators, whatever, and they're arranged in columns and rows. So you might have something like A, B, C, D. This would be a matrix where A, B, C, and D are the elements of the matrix. And so it could be something like, for example, 1, 2, 4, -3. This could be a matrix. It contains the elements. We were told, or we were given kind of the standard notation for naming which element of a matrix we're talking about. So for instance, if I wanted to talk about the 2, let's call this matrix M. Well, this 2 here is in the first row, second column. So we would say matrix 1, 2, matrix element 1, 2, in this case, is equal to 2. Matrix element 2, 2, that's the second row, so first row, second column, and that would be -3. Okay, and that's just notation, right? You have a matrix that contains a bunch of elements. The matrix might be a square matrix where the number of rows is equal to the number of columns, or it might not be, whatever. And when we want to pick out a particular element, we say it's the row, comma, column element. Today, though, we're going to continue talking about matrices and what things we can do with them. Last time we saw we can add matrices together. And it's just like adding vectors together. You would add element by element. So 1, 1 added to 1, 1, 1, 2 added to 1, 2, and so forth. Today, though, I want to talk about multiplying matrices. So to get to there, the first thing we want to do is talk about multiplying a matrix times a vector. It turns out that once we can see how to do a matrix times a vector, we could just generalize it to see how you do a matrix times a matrix. So say we have matrix M is A, B, C, D, and we have the vector V is E, F, right? So we have a 2 by 2 matrix and a 1 by 2 vector, a column vector of length 2. And what I'd like to do is multiply these two things. So we would say the matrix times the vector. And we want to know how to do this. Well, let's go ahead and write down what this looks like. We have A, B, C, D times the vector EF. And it turns out that the way you do this is kind of an interesting type of thing. What we're going to get is a vector. So you multiply a matrix times a vector, you get a vector. The vector will have the same length as the vector we were originally talking about. And of course, the matrix and the vector have to be of the same size. So if we have a column vector of length 2, then the matrix has to have a column of 2, column length 2 as well. So we're going to get a vector. So here's our vector. And the way we get the numbers is the first element, so the top number in this vector, I'm going to do in blue. And it goes like this. You take A, the first element of your matrix, times the first element in your vector, A times E, and then you add to it the next element of your matrix times the next element of your vector, B times F. And there we go. We've gone all the way across the row of the matrix, and we've gone all the way down the column of the vector. and that gives us the very first element of our new answer vector. Then, to get the next element, the second number in our answer, we take the first element in the second row times the first element in our column. So now it's C times E. And then the next part, we add to it the next element in this row times the second element in the vector. So D times F. And then, of course, we've gone all the way across the rows, all the way down the column. And this is the answer. Okay, so it's kind of interesting. You go top left, top element, multiplied, plus next element times next element, plus next element times next element, and so forth, going across the rows in the matrix and down the column in the vector. Add up all those terms, and that's the first element of your answer. To get the next element, you go down to the next row, and again, you're going to go across the matrix and down the vector. So the first element times the first element, plus the next element times the next element, and so on. So let's do an example with some real numbers here. Let's say we have a 3 by 3, 1, 2, 3, negative 4, 1, 0, 3, 1, 2. Okay, there's a matrix. And I'm going to multiply. Notice there's 3 rows here, so there better be 3 elements in our vector. Let's have it be 1, 2, 1. Okay. All right, so the answer we're going to get is going to be a vector of length 3, because we're starting with a vector of length 3, and it's a 3 by 3 matrix. And now we're going to do the first row times the column of the vector, and we're going to go across. So we're going to get the first element, 1, times the first element of our vector, 1. I'm going to add the next element, the 2, times the next element of the vector, the 2, plus the next element is a 3, times the next element in our vector is a 1, so 3 times 1. And I've now run out of elements. So I've gone all the way across the matrix, and I have my 3 terms there. I would add all those terms together. Oops, let's do this in black. And I get a number, and that number is the first element of my answer. Next, let's go to the second row. So now the second row, I'm going to go across, and I'm going to go down the vector again. So now the first element of our second row is negative 4, times the first element of my matrix, 1, plus the next element is a 1, times the 2, plus the last element is 0, times the 1. Okay, done that row, finished with him. I now move on to the last row of my matrix. So I'm going to get the last element of my vector. And I'm going to go down again, my vector. So the first element is a 3, so it's 3 times the first element of my vector is a 1, plus 1 times 2, plus 2 times 1. Okay, I do all this adding and all of this multiplying. So the first element there, I'll do it in blue again. 1 times 1 is 1, plus 2 times 2 is 4, plus 3 times 1 is 3. So 1 plus 4 plus 3 is 8. The second element, negative 4 plus 2, that's negative 2, plus 0, so negative 2. And the last element, 3 plus 2 plus 2, so 3 plus 4 is 7. That's in red. And there we go. There's the answer. You have a matrix times a vector. The answer you get is a vector whose elements you get by going across the matrix multiplied by going down the vector, and you're adding all of those terms up. So first row times the vector gives you the first element of your new answer. Second row times the vector gives you the second element, and third row times the vector gives you the third element. Now, The next thing we want to do is, what about if we have a matrix times a matrix? So let's say we have the matrix M is A, B, C, D. And we have the matrix N, which is E, F, G, H. Now we want to multiply these, so we want M times N. Okay, well, writing it out, we have A, B, C, D times E, F, G, H. Okay? So how do we go about doing this? Well, it's kind of the same thing. If you notice, we have a matrix on the left, and now on the right, instead of a single column vector, we have a matrix. And all that means is we have like multiple column vectors kind of combined into one object. So if we forget for now, let's pretend like this part of the matrix on the right is gone. So erase him from your mind. All you see is the EG part. If we were to multiply that vector EG times the matrix, what would we get? Well, we'd get a vector, one column, and it would be A times E plus B times G, right? And then for the second element, we'd go to the second row of our matrix, C and D, and I would multiply times that column EG, so C times E plus D times G, right? So if we didn't have a matrix N, if it was just a vector EG, and we multiplied the matrix M times that vector, this would be the answer we would get, just like before. However, we don't just have a vector sitting there, we have a matrix sitting there, which means we have more, oh, that's too big there. We have more, let's do this. Oops. I don't know how to get a smaller eraser, so let me just erase the whole thing. We have more columns sitting here. One more column. So let's just pretend now that this left column is gone. He's not there anymore. And now we have the right column sitting there. So it's like we're about to get another column vector answer to the right of the first one we just did. And what's he going to be? Well, it's the same thing. We go across our original matrix and down this new column. So the first element we get would be AF. And then the next element, BH, so plus BH. So that's the first element of the new vector, column vector sitting here. And we go to the next row, so C and D with F and H, so C times F plus D times H. So if that left side column didn't exist, and it was just the right side column, if we multiply our matrix M times that column, we get that column vector sitting there. But now we see this is 4 elements, the first element, second element, third element, fourth element. So we have a matrix. And this is exactly how you can think about doing matrix multiplication. You're basically just doing the multiplication of a vector and a matrix multiple times, because your second matrix, the N matrix, is basically composed of multiple vector columns. So let's do an example, just like we did before. Example. Let's say we want to multiply 1, 3, negative 2, 4 times 5, minus 1, 0, and 3. So what are we going to get? Okay. So we start with the top row of our left side matrix times the left column. So it's like this row times that column. And we're going to get 1 times 5 plus 3 times 0. Okay. And then to get the element below it, we now go to, let's do this in green, the bottom row with the left column. So negative 2 times 5 plus 4 times 0. Now, we're done the left column, so we don't need this left column anymore. Now we're going to go to the right column of our secondary matrix, our N matrix over there. Well, we start back at the top, so we go back to the top row, And we're now going to do the right side column. Okay, so now we go to the next column of our answer. We have 1 times negative 1 plus 3 times 3. And then in red, we did the top row, so now we go to the bottom row, and we're still on this right side column. What do we get? Negative 2 times negative 1. Oops. Plus 4 times 3. Okay. And now we're done. Now we just kind of clean up these numbers here. So the top left, the blue element, 1 times 5 is 5, plus 0. Sorry, 1 times 5 is 5, plus 0 is 5. Bottom left element, negative 2 times 5 is negative 10, plus 0, that's negative 10. The yellow one, 1 times negative 1 is negative 1, plus 3 times 3 is 9, so 9 minus 1 is 8. And then in red, we have negative 2 times negative 1 is positive 2, plus 4 times 3 is 12, so 2 plus 12 is 14. And there we go. That's our answer. So, obviously, this can get tedious if you have really large matrices. There's lots of rows and lots of columns. But if you try in your mind or you do it on the page itself, you block out little columns and rows, all you have to do is think about how do I multiply a matrix times a column vector, and you're just going to do it for every column in your second matrix. If you have a 2 by 2 times a 2 by 2, the answer you get is a 2 by 2. Just like if you have a matrix times a vector, you get a vector. The length of that vector is the same as the length of your original vector. Okay? But at the end of the day, on the left side matrix, you're going across the rows. On the right side matrix, you're going down the columns. You multiply and add the terms together for each element individually, and that gives rise to your final matrix answer. Okay? And that's how you do matrix multiplication. Anyway, I hope this is understandable. If you have any questions, of course, you're always welcome to email me, ask me. I will be doing another video with some more examples and such, but for now, this is the theory. Practice this. Make sure you see where these numbers are coming from, and I'll see you later.